Okay, we are looking at cube roots today. If you guys take a look at the very first one, can you just cross off the -5? We'll just make the first one our parent function, y equals the cube root of x. So we remember what it looks like, how to graph it, and then it's all the same steps. I just move it h and k units wherever I need to, and I might need to stretch it or shrink it, depending on if I have a number out in front. Okay, but let's talk about this parent function, y equals the cube root of x. Do you remember what the shape was? It doesn't really have a name, but do you remember kind of?
The parent function, but also like.
Yes, it was like the stretched out S. It's almost like remember the square root was just that? Well, this one also does that on the other side. Okay, so that's kind of our basic shape. So I'm really just going to plug in things that are perfect cubes and see what comes out. The smallest thing, well, I can take the cube root of 0, can't I? What comes out? 0. So 0, 0 is still a point on my parent function. I can also take the cube root of 1. What do you get out? 1. So 1, 1 is also a point on this graph. But I can also take the cube root of -1. What's the cube root of -1? -1. Okay. The next perfect cube that's on my graph here is going to be 8. What's the cube root of 8? 2. So at 8 I get out a +2, and then I can do the same thing for -8, and I would get out -2. So that's kind of what my graph looks like. When you connect them, you want to make it as smooth as you can. It's not jagged, it's a nice smooth curve, and your arrows will continue forever in both directions. I can take cube roots of negatives, I can take cube roots of positives, I can take cube roots of every number. Alright, so there's my parent function. And now I'm just going to shift this around like I have done every single other graph. But you need to make sure that you are able to create the parent function to start off with. Okay, because I'm not going to give it to you every time. So I have that, and now I'm going to do whatever I need to do with it. So if I look at number 2, what does a +1 on the outside tell you to do the whole graph? Where do you move it? Up 1, right? So you don't have to redraw the parent function every time if you don't want to, but I will just so we can see it. So there's my parent function, and then I just take each one of those points and I shift it up 1 unit. And in this case, that's it for my final graph. Easy enough? Let's jump down to number 4. That's fine. So again, I like to start with the parent. You don't have to, but I think it's easier. What does a +2 underneath the cube root tell me to do with the whole thing? Left. Whatever is in there with the x, you always do the opposite of what you see. Because remember, the formula is a -h. Okay? So that would indicate a left 2. So I'm just going to pick everything up and move it left 2. So yeah, some of these are off my grid, but that's okay. I can approximate. And then let's go ahead and why don't we jump forward to something like 7. Sorry. All right. Now this one, if I am multiplying by a 4 out in front here, what do you think that's going to do to my whole graph? Right. Now, instead of kind of being this sort of stretched out S, it's going to be a little bit bigger, so it's going to be a little bit more dramatic, so it'll be more kind of like this. instead. So they both just get bigger. Okay? So I would still start with the parent. And then just like before, all I have to do is multiply all my y values by 4 in this case. Okay? So let's just start on the positive side first. 0 times 4 is still 0, so I'm still going to have a point right at the origin. And then this point, instead of being 1 at 1 comma 1, it'd be at 1 comma 4. And then this point over here, instead of being at 8, 2, is now going to be at 8 comma 8. So it's quite a lot bigger. And then the same thing happens on the negative side. So you're now going to be at negative 2. Oh, I'm sorry, not negative 2, negative 4. What am I thinking? And then also, instead of at negative 2, we're now at negative 8. So my graph now looks like that. Quite a bit bigger. And now, all I have left to do is, if there's a plus 1 under there with the x, that really means to go, which way? Left 1 space, exactly. And there we have it. So the green is my final graph. So, do you see how once you get the process of picking up and moving it, or stretching it or shrinking it, you can apply it to any type of graph, as long as you know what the parent function is. So you can now graph all of these the same way. Cool! Alright, let's just jump to 11 and get one of these crazy weird ones out of the way. And it works the same way as the other ones. This is not in the form that we're used to. So just like with the absolute value or the square roots, I factored out this coefficient in front of the x. I'm going to do the same thing. So I'm going to rewrite this like this. Y equals cube root. Can I factor an 8 out? So I'm going to do that. 8 times x plus 3. And then I have that plus 1. Do you see what I've done so far? Just factor the 8 out from underneath the radical. And then I can split them up just like I was doing before. So I'll have the cube root of 8 by itself, and then the cube root of x plus 3. But I know the cube root of 8. It's just 2. So now I have it in the form that I'm used to. So if you want to take a minute and now graph that, and let's see if we all end up in the same spot. So don't look up at my screen until you're done with your graph. Okay, hopefully you have the same graph that I do. So I started with the parent function and just the black pen, and then I had to multiply all the y values by 2. So that's in orange. And then you have to take that orange graph and shift it left 3, up 1.
Wait, why did you multiply by 2?
So there's a 2 right there. This original's not in that form, right? So you can't graph it as it is there. So you have to rewrite it so that it's in our form. So that's actually I mean, they're equivalent, right? Though it's the same math problem. It's like 1/2 and 4/8, same thing. But I can't graph it in this form. So once I rewrite it like this, I can. So if you have a final graph, let's just spot check a couple of our points. Your kind of middle point there should be at -3, 1. You should have another point at -2, 3. And another one at -4, -1. So hopefully if you have those couple of points, the other one should line up too. Does this make sense? I mean, they're all the same. It's just a matter of having the right parent function than doing what you have to do to it. Okay, so that's pretty much it for the cube roots. I did mention that I want to do cubic functions with you, and that's not a cube root. That's when you have x to the third. So what's interesting about having x to the third is it almost looks like the cube root, but instead of it looking like this, you sort of turn it vertically. So if you could, let's see. Let's take one from the second page. So if you go onto your second page and you look at number 13, let's cross off everything that 13 says, the whole thing. Let's just use this grid to write this parent function, y = x cubed. Let's start with positives and then we'll try some negatives. So of course I can plug in 0. What's 0 cubed? 0, so I get out of 0. Let's plug in 1. What's 1 to the third? 1 times 1 times 1 just gets me out 1, so 1, 1 is another one. But now plug in 2. 2 to the third is 8. So 2, 8 is your next point. And then, I mean, you could do 3, but you're going to be way off the chart because 3 to the third is already 27.
Oh, I see how it works.
Yeah, so now we're sort of rotated. So now let's do some negatives. -1 to the third power. -1 times -1 is -1. -2 to the third. What's -2 times -2 times -2 is -8. And then again, I'm not going to bother with -3 because it's off the chart. So when it's the same as that cube root graph, it's just this way instead. And all the same rules apply. So if you had something in there with the x, then it's going to tell you to shift it left or right. If there's something on the outside, you move it up or down. So let's cross off 14, and we'll recreate that one as, let's do a parenthesis, let's do x, let's do +2, close parenthesis, cubed, and then maybe, I don't know, -1, whatever. So, you see that it's a cube, so you're like, oh, okay, this is a cubic function. So my parent function would be exactly what we just made. Okay? So let's go ahead and I'm just going to recopy that parent function again. 2, 8, 2, -8. Okay, so there's that one. And then if I have a plus 2 in there with the x, what is that really telling me to do with my graph? Left 2, exactly. When it's in there coupled with the x, that's a left or right. That's your h value. So I'm going to pick everything up and I'm going to move it to the left 2, and then this minus 1 out here tells me to do down 1. So I can do both of those at the same time. I usually start with the center point and then I go from there. You can do it however you like. Left 2, down 1. So there would be my graph. Now you can have numbers out in front that stretch or shrink things just like we have had before. So let's try, let's just cross off 15 and we'll make up a new one. Let's make this one 2 times x minus 1 cubed. Let's do it just like that. So we'll start with the parent. Okay, so the 2 out in front means I have to multiply all my y values by 2, okay? And then I'll worry about this later. So let's concentrate on the multiplying by 2. So 0 times 2 is still 0. Instead of having 1 comma 1, it's now going to be at 1 comma 2. And instead of being 2, 8, now it's 2 comma 16. It's just so far off my graph. So I just know that it's way up there. And then the same thing happens in the negative land. So instead of negative 1, now it's at negative 2. And then I would be at negative 16. Okay, and then all I have to do, if there's a negative 1 in there with the x, that tells me to do what with this graph? Pick it up and move it to the right one. So each dot just gets moved to the right one. And that's pretty much it. There's my final graph in purple. So no matter which one we're trying, my steps are pretty much the same every which way. Okay, so that's all of them. Now I think we've done all the ones that we're going to do. There's another one, but I don't think we're going to bother with it. It looks like this guy. Anybody have any guesses how you get a graph that looks like that? I'll tell you. That's when you have x in the denominator. That's the graph of y equals 1 over x. And then I think this one shifted up a bunch of units. But that's how you get those two. Because think about it. You can't ever have, what are you not allowed to have in the denominator, ever? A 0. You can't have a 0 in the denominator because then everything breaks. So see how there actually is no graph when x is equal to 0. You can get super close to it, but you can't actually get there. So it forms something that we call an asymptote. You'll learn more about those in Algebra 2. Okay, so let me give you this, and we'll try a couple of these, and then maybe you guys can do some on the board if you want. Let me actually stop this video.